This is part 2 of our lesson 4.3. We're talking about our transformations. On our last slide, we looked at the pre-image and the image. We mapped up what figure went with what. So which point goes with this point, which segment goes with this segment, so on and so forth. We can do the same thing with a mapping statement. I'm not real sure why this didn't come out so clear. This is triangle XYZ maps to, this should be a triangle as well. I don't know why that turned out like that, but that should be triangle ABC by reflection. When you have a statement, that is the most powerful thing you can have. You don't necessarily need the picture to figure out what goes with what here. What is the image of point X? It would be point A because they're both the first letter. What is the image of segment YZ? It would be segment BC. That segment goes with this segment. Second and third letter, second and third letter. What's the pre-image of point B? Be point Y. What's the pre-image of segment AC? Segment XZ. What is the image of Z? Point C. What is the pre-image of segment CB? It'd be segment ZY. This is an example using game software like Tetris. So the goal was to move the shapes into congruent spaces where they'll fit so the completed rows can be eliminated. Describe a combination of transformations that can be used to move this game piece A into congruent space B. Well, if you're playing Tetris, probably the best thing you can do first is to slide the figure to the right. So that would be a translation. Then you could rotate the figure so that this block ends up down here. Now, technically, maybe you could rotate and slide, but it looks like if you rotate first that this piece might land down here. So if you were actually playing Tetris, you would have to watch out there. If you click on this link, this will take you to a free game of Tetris where you can practice your transformations.